long time ago now, at the beginning of 2022 in fact, and this is April 23, I did a bunch of experiments on the alternator and the load items such as headlamps, what have you, on the electrical system. And the reason I was concerned about that was because of the fitting the alternator, because the one that comes as standard with the AJ30 is a bit too large and in the way for the installation in the Gilbern. Anyway, I've just done a bit of a recap on all of that and kind of slimmed it down, and in the end of this sequence there will be a bit of a conclusion. So this, as you'll remember if you've seen the previous videos, this is my Jaguar S-Type AJ30 engine, and I changed the sump on it because there was a large sticking out piece which got in the way of the chassis. But that leaves me with problems regarding the air conditioning, which I want, and also the alternator. So the alternator on the S-Type uses this mounting here and one on the sump, but in the X-Type sump there just isn't one. So I have a problem to solve here, but it's worth noting that the distance between here and here is limited in the car by the chassis rails, which come very close each side. Now, I could probably make my own bracketry to pick up on the sump bolts here, for example, to mount this, but it would be great if I was able to push the whole thing in slightly. I can see there's quite a lot of clearance in here, and so measuring that distance between the extremities looks like around about 55 centimetres. And just to confirm, I've just put the ruler in the chassis, and you can see the distance here between the chassis rails is indeed maybe 57 centimetres. One of the questions that arises is how big the alternator I need. How big actually is it? This is 120 amps, so it's fairly chunky, as you can see. And it'd be quite nice to get a smaller one. But the question is, how big does the alternator need to be in terms of its output? I will just point out the very small size of this Nippon Denso alternator, which this car has been running for some time. The output, I believe, is 40 amps, but there's not a heck of a lot of electrical systems in this car, and what's more, it doesn't get used at night very often either, so we don't really know with a great deal of detail whether this alternator is powerful enough or not. So because these typical spade terminals make a very good fit to replace your typical blade fuse, so yeah, basically the end of this fuse is almost exactly the same as that spade clip. So what I'm going to do is I'm going to crimp the spade terminal using these rather ancient crimpers. I'm going to crimp it onto the test lead. So one spade terminal on the end of our test lead. Okay, two crimped on spade terminals. I'm going to put this in ammeter mode. I'm going to put this into the fuse. Into the fuse box. So when I switch everything on, I should be able to get a reading how much current the fuel pump is taking, because this fuse is in series with the fuel pump. There's actually two fuel pumps because there's also a swirl tank, and I'll see how much that is. Start. And as you can see, we have 10 amps going to the fuel pump. I wonder if it changes if I rev the engine up. Not really. Right, so I've done a similar thing. I've put the spade terminal test probes into the fuse box instead of the fuse that runs the ECU. So let's do the same thing again. Start it and see how much current. Okay, this is showing just about 1 amp. I'm going to rev the engine up. Okay, there, I think we saw about 2.4 amps. So I don't know what rev that was, maybe 5,000. So 2.5. Yeah, so that's 2.5 amps on a 4-cylinder engine. You can imagine that being maybe 4 amps on a 6-cylinder engine, plus the 10 amps that may be the same. So that's kind of 14 amps just to run the engine itself. So as part of my current loading calculation, you might even call it a power budget, I'm going to measure the current draw from an LED headlamp. And what I'm going to do is I'm going to connect it to a power supply and see how much current is taken. I'm not sure if his main will dip. I'll point it away from you. I'm not sure if his main will dip, to be honest with you, but it's showing 0.9 of an amp. And then the other side, 0.46 of an amp. So I call it half an amp and 1 amp, really, main and dip. So a bit more, I've got a LED stop and tail light. Now I'm not totally sure I'm going to use these, but I'll certainly do as a model of what it could look like. So I'm going to do the same things before. So that's obviously an indicator light, and it looks like it's drawing 55 milliamps. 55 milliamps. 55 milliamps from an indicator light. 45 milliamps from a presumably stop light. Tail light. And 58 from a tail light. Sorry, 58 from a stop light. So 58 for a stop light. 45 for a tail light. And 55 for an indicator light. So I continued my analysis of the electrical load items, having done the most difficult part by far, which was to discover what the engine requires. As well as the lights, I also looked at obvious things like non-LED headlamps and the electrical fan, the heater fan, a heated rear window, and so on, to come up with the final figure of what the electrical load actually looks like. So you can see I've got a little bit of a problem here, especially if I choose to use standard non-LED headlamps, which I have kind of decided to do. 55 more or less amps is over 40, obviously. If I did stick with LED headlamps, which I was thinking of doing at the time, and it's just barely within the limit. So I have a problem with using that micro alternator, and even if I used LED headlamps, I think that that's just too marginal to be worth considering, especially for a road car with other things in it like stereo and etc. So what to do? That's the question. Now clearly the amount of space down here is quite restricted, especially when I need to get an alternator in, which would normally sit down here somewhere. Makes it even worse. So what I'm wondering is whether I could actually remove the water pump. and put the alternator in where the water pump is, and that would be something like this. The thing about alternators as being AC devices with a rectifier built in, I see no reason why they shouldn't go backwards. It just means the rectifier would work in the opposite direction, and I don't think there's any problem with that at all. The beauty of it would be that I could also use the same mounting points as the water pump currently does. And of course, I should mention that concept would then involve using an electric water pump. I should point out that the water pump on this engine, the AJ30, is not within the engine block. So the actual physical pump is this thing here, and it's not built into the block. So here's the concept with the water pump removed. So the alternator itself would sit in this space, mounted to the 3 mounting points which were previously there for the water pump. Right, so here's my going the next step beyond proof of concept into what I suppose you might call prototype. So we now have a bracket fitted to the original water pump mountings, and there's the prospect there of a permanent welded structure to hold the thing on. Yeah, another thought, because of course an alternator is normally mounted on 2 lugs here, which swivel, the whole thing swivels that way, and the adjustment, if you like, is fixed on here. Now if this plate is continuous all the way around and a lot thicker, assuming that the positioning is correct, it does offer the possibility that this lug here doesn't need to be supported at all, because the whole thing is supported on its front face. Yeah, so I've got my alternator mounted back to front, as it were, where the water pump used to be, and it is only temporary because it's quite thin, this plate, but even so it's pretty strong. Now all of that was all well and good, but of course the whole concept hinges on whether in fact I'm correct that a alternator can be made to run backwards and still operate normally. Now I will drop in at this point that Honda engines typically are mounted the other way around to most others, and presumably they don't have specially made alternators that run backwards, so I was very confident. Nevertheless, I thought I might as well test it, and here we go. Quite a while ago now, I was getting myself in a real pickle with a little alternator like this and being able to wire it up properly. Now, long story short is that I had the 2 wires to the back of the alternator connect up back to front. That's all fine, but I wanted to push that discussion forward to another issue that I'll come up to in a second. Now the first thing I had to be able to do was to reproduce the experiment that I did kind of a year ago. So could I get the ignition warning light, which I was using this bulb here, to come on? No, I couldn't. In fact now, well, as I demonstrate it to you now, I can see now what the problem is. Actually it is glowing, isn't it? Very slightly. But I didn't notice that, I just thought that it wasn't coming on. So it was quite a while before I realised, that's real life, live experimentation, noticing that. So having noticed a couple of little sparks, I realised of course that the 21 watt, I don't know, indicator bulb or something was just too powerful. So anyway, here we have it, by means of a 10mm bolt head. I'm able to connect up to my drill, which is better than I managed previously. And here we go. So and that works, of course. So that's good. At least we're back to where we were a year or so ago. And in fact, if you check the voltage on the bulb. Now that's 12.22 volts is not that impressive, to be honest. But that's because the drill isn't really fast enough. And that's all fine and dandy, so no need to put it in the car, which is what I did last time. But, and this is where we move on, the other part of this was the fact that if you look in my Gilbern engine bay, you'll see that the alternator is facing forwards. And that means, by the way, mimicking the position of the water pump as it originally was on this engine. But that means it runs backwards. Now, I was thinking to myself, alternator means it works on alternating current and has a rectifier built in. It should work backwards, just as a standard thing. So, let's prove whether I can have a reverse alternator. So, normal forwards. And now we're going to put the thing into reverse. Yay! Okay, that's slow, but we still had 12.2, and this is on DC volts. There is no sign of a negative voltage happening here. So there we have it. The alternator is quite happy to run backwards. Just some actual close-up measurements so you can see the meter. So normal forward running. We have 12.06, 12.3, and then, because that's not very impressive, do the same thing with a faster drill. So, 13.2, and now the same thing in reverse. So we are going backwards. That's got 12.5 volts, and again, because that's not very impressive, we'll use a faster drill. So there we have it. Although I was pretty confident that the alternator would perform normally while running backwards, such a lot of this had other things hinging on it, like the position of the steering shaft and the position of the exhaust manifold, which I am working on. This is real time in April 23. That needed to be absolutely certain in case I'd got a massive problem that I didn't actually know about. So proving that the alternator worked normally while running backwards was extremely important before I did anything else, especially on that side of the engine. I'm remarkably kind of relieved in a way, even though I was confident, but this is extremely good news for the rest of the project. Great stuff.